Hello everyone, my name is Doğa Yasa and I'm from Technical University of Munich. Today I will be presenting to you my research on modeling heterogeneous fleets for autonomous mobility on demand systems, or AMODs. As we know, the deployment of AMODs has the potential to revolutionize urban mobility. However, implementing the necessary infrastructure for a fully autonomous fleet is both time-consuming and expensive. Therefore, in the transition period, cities will likely to operate a mix of autonomous vehicles and human-driven vehicles, or HDVs. To effectively manage this transition period, we offer a model in FleetSpy, an open-source AMOD simulation framework that captures the behavior of human-driven vehicles. The key distinction between autonomous vehicles and HDVs in our model lies in their availability. While autonomous vehicles can operate 24/7 without any brakes, HDVs are constrained by factors like shift brakes, charging brakes, or adherence to working hour regulations. And in the simulation, the passengers can't be picked up during these unavailability time frames. For scenarios where real-world data is available, these behaviors can also be configured. So we conducted a week-long simulations that uses two different configurations for HDV shift settings. The first one is based on recommendations from International Labour Organization, ILO. And the second one is adjusted based on a survey from NYC taxi drivers. Now, let's look at the results of our experiments. Figure 1 and 2 show the variation in the number of inactive and active vehicles throughout the day under two different shift configurations. And as you can see, not all vehicles are active simultaneously. NYC settings have longer shift durations and show more vehicles remaining active, meeting the passenger requests. On the other hand, the ILO settings with shorter shift durations lead to fewer active vehicles because of the limited weekly shift time. So this results in a lower request completion rate for ILO compared to NYC settings. In addition to this, we explored integrating autonomous vehicles into the fleet. We varied the heterogeneous fleet comparison by gradually increasing the number of AVs from 0 to 100 while reducing the number of HTVs to maintain the request completion rate of at least 95%. The results in Figure 3 indicate that introducing 100 AVs can replace up to 2,500 HTVs for the given demand. So in conclusion, our research paper offers a configurable HTV model for simulating heterogeneous fleets, filling a critical gap in the field. By comparing two different HTV settings, we gain insights into differences between real-world behaviors and recommended practices. Last but not least, the study demonstrates the potential of AVs to significantly reduce the number of HTVs required to meet demand, although further considerations like economic feasibility and maintenance must be factored in. Thank you for your interest.